Hello, everybody. This is Phishing Detection with LLMs by Richard Aldrich and Christopher Card. Starting with our problem motivation, the motivation for using an LLM to detect phishing lies in the problem that humans are the weakest link in security. The majority of data breaches that occurred in 2024 involved the human element, whether that was simply human error or social engineering, like phishing. This human element is important to address because even when the rest of a company's security holds, such as network security, secure software, and secure hardware, an attacker can work around it by manipulating a human instead. Whether it is an employee to get access to a company computer, application, or information, or an individual to get access to their personal information, possibly for identity fraud or banking information to steal funds. Phishing also needs a low technical skill set, opening up the company to a lot more attackers and attacks from this vector when compared to attacks on hardware and software, which need a more technical skill set to accomplish. Another important note is the trend in the field of cybersecurity that involves using the same tools and metrics adversaries use to attack a system to defend that system as well. While an attacker may use network tools to analyze packets for possible attacks, a defender would use those same tools to find problems in their network security to address them. This idea could be and should be expanded to the protection against phishing attacks, as LLMs are already currently being used to make phishing attacks more realistic and spear phishing easier, which makes it vital for defenders to use LLMs to detect these attacks. The main objective of this project was to deliver an LLM fine-tuned for phishing detection. That is, the LLM can be fed a dataset of emails and accurately detect which ones are phishing and which ones are legitimate. At the same time, we wanted to gain important knowledge and experience on LLMs and fine-tuning, as well as on phishing itself. The phishing dataset obtained includes over 82,000 total emails, close to 43,000 being spam or phishing. The determination of phishing is based on subject lines, email body text, labels, and sender and recipient information. The legitimate email dataset used was made from a set of real emails from users at the company Enron, mostly from upper management, making it the perfect dataset to use for training an LLM for phishing detection. These files had to be installed locally using 7-zip to make sure the environment variables were correct. When it comes to tools, Python was the language used to create the scripts, with many libraries needed, listed here, a few being Torch, Pandas, Scikit, and TensorBoard. The LLM used was Roberta, which is a robustly optimized BERT approach, which is similar to BERT LLM, but better for being pre-trained. The LLM was fine-tuned with LoRa technique, or low-rank adaptation, which can train an LLM effectively while saving a lot of memory. Our methodology, as outlined in Richard's GitHub README file, as mentioned, involves fine-tuning a Roberta LLM with LoRa. This includes using a virtual environment, installing all the required libraries listed on screen, extracting the dataset into a new folder, then using the scripts to randomly sample the datasets and correctly label them as legitimate or phishing, and fine-tuning Roberta and LoRa with that dataset. Randomly sampling an even smaller set of emails from the total dataset to not crash the program when running, we can run the program to then evaluate the dataset by having fine-tuned Roberta label the emails as phishing or legitimate, outputting a matrix, and comparing the results with the actual label on whether they were phishing or not. This methodology leads to the solution design where weighted average F1 precision and recall scores are outputted to get the overall accuracy of the LLM, along with a confusion matrix graph so that false positives, false negatives, and correct predictions could be analyzed. With an accurate enough output, our objective should be fulfilled as a result of running the script. Looking at the matrix for analysis, the true label of the email given for the dataset is on the y-axis. That is, whether the email is truly legitimate or phishing. And the x-axis has the labels given by the LLM. That is, which ones are fine-tuned Roberta predicted to be legitimate phishing. Out of 3,112 emails that were truly legitimate, fine-tuned Roberta correctly labeled 3,852 as such, meaning there were 60 false positives, or 60 emails marked as phishing that were actually legitimate emails that should not have been detected. Out of 2,097 emails that were truly phishing, fine-tuned Roberta correctly identified 1,978 as such, meaning there were 119 false negatives, or 119 emails marked as legitimate that were actually phishing and should not have been detected. These results give overall precision, recall, and F1 scores all around 97%, as shown on screen, giving an overall accuracy of about 97% as well. How high an LLM's accuracy needs to be and how low its false positives and false negatives need to be is based on the task at hand and the type of company it may be used at. The damage that could be caused from a legitimate email not making it to where it is needed, or a phishing email reaching where it shouldn't and having an employee fall for it, would need to be part of a company's risk assessment, which would be very different from company to company, such as a restaurant compared to a military service. And 97% may be viable for the former, while the latter may need an accuracy of even higher than what we obtained. On an individual level, a 97% should be viable for checking personal emails, as most email systems already have built-in spam filtering, and using an LLM on your email after would just be extra safe. While individuals should also receive less emails total than a company does, and thus less phishing ones as well. Overall, the objectives of the project were achieved. We used an LLM to accurately detect phishing emails from a dataset, getting 97% accuracy from the random sample, while keeping false negatives and positives relatively low. The outcome of the test provides a strong case for LLMs being viable for phishing detection, and a strong start for further fine-tuning to improve accuracy. We also got further insight and hands-on experience into how fine-tuning an LLM works, using LoRa to fine-tune Roberta, while also gaining more knowledge into areas of an email that can be deemed as suspicious, such as sender information, body, and subject lines, fulfilling both of our objectives. Thank you for listening. We will now answer a few questions we thought you might have. The first possible question we thought might be asked was what the starting point was for fine-tuning the LLM. This involved using a base version of Roberta that was then ran with LoRa fine-tuning, giving the LLM samples of both legitimate and phishing emails from the dataset before even giving them the metrics to predict them, and assigning these two options, legitimate versus phishing, values of 0 and 1 respectively. Then processing a large subset of the total data with these 0 and 1 labels that can then be compared to when the LLM makes its predictions. Another possible question we expected was more specific about what variables indicate phishing in emails that our code looked at. As we simply stated earlier, areas such as the body and the subject. More specifically, keywords were looked at in all of these areas, as phishing emails typically include words such as click, account, urgent, verify, suspend, alert, and more, which could be checked for in all emails in the split-up dataset as phishing indicators. And that indicator, paired with the operations that come with how Roberta already is at its base state, can lead to accurate predictions. A final question we thought we might be asked, mostly out of curiosity, was how long this whole process took. So creating a virtual environment for start takes a couple of minutes. Takes time to locally download the huge data sets and manually put them in the format and folders needed. Running the actual script to fine-tune with LoRa took hours on Richard's computer. And then running the actual test itself actually only took a couple minutes. But then, of course, there's the hours across a few days of altering scripts and testing them until they worked. Overall, it was not as difficult as expected, and we learned a lot in the process and are happy with the results.